Yes.
Yeah, yeah,
Yes,
it's
visible,
visible.
sir.
Okay. Because I have to maintain attendance for 3 days. I'm getting lots of confusion in your register number that we can do at the end of the session because I have made a note of all the names of the students who joined the session. There is no need to worry about the register number. At the end of the session, you can tell me who have joined recently.
Okay, sir.
Okay. Are you from the same batch, MSc IT?
Yes, sir.
Yes, sir.
Uh, is anyone joined from MCA or BCA?
No, sir. MCA has different classes.
Okay. See, you know the name of the subject is computer architecture, right? So, I mean, this session starts 2 to 5, and 3 days class will be there today, tomorrow, and next Saturday. So today we are going to discuss. First, let me introduce about myself. So I am Chinnaparaj, working as a professor in Presidency College. And if you don't mind, I tell you what's my qualification. I've done MA, MSc, BEd, MPhil, PGDSC, postgraduate diploma in special education, and I'm doing my PhD in computer science. Okay, working as a professor in a college. I mean Presidency College. See, first unit, these are the unit. Okay, but I have to go a little bit faster because we have to wind up the class by 3 days. Um, so I have to I have to take this class very faster. So just listen carefully. So this is your unit one. Unit one consists of data representation, data types, complements, fixed point and floating points representation, other binary codes, micro operations, register transfer language, register transfer, bus and memory transfer, arithmetic, logic, and shift micro operations, arithmetic logic, shift unit, microprogrammed control, control memory, address sequencing, microprogram example, design of control unit. So these are your unit one. Uh, See, you know Hema madam, I have finished MCA class and she said to me that to send notes to her. She may share the notes to your WhatsApp group. I'll give a call to her. If she can, and the end of the session, I will send notes to your WhatsApp now. Any one of your WhatsApp number. There is no need to worry. The notes can be shared at the end of the class. Shall we start the class now?
Yeah, sure, sir.
Yes, sir.
Okay. So
Thank you.
if my voice is not audible for more than 30 minutes, or if my screen is not visible, um, just send me a text message, or you can unmute your mic and tell me my screen is not visible and your voice is not audible. Okay.
Okay, sir.
அதில் வந்து என்னென்னா கொஞ்சம் கேல்குலேஷன் பார்ட் வரும், அதில் கொஞ்சம் கேர்ஃபுல்லாக இருங்க. இஃப் யூ டோன்ட் அண்டர்ஸ்டாண்ட் யூ கேன் ஆஸ்க் மீ, பட் வி ஹாவ் டு கோ ஃபாஸ்டர். சரியா? கொஞ்சம் செஷனில் கொஞ்சம் ஃபாஸ்ட்டாக போக வேண்டியிருக்கும், கொஞ்சத்தில் கொஞ்சம் ஸ்லோ போக வேண்டியிருக்கும். பட் புரிகிற மாதிரி இருக்கும், புரியாத மாதிரி இருக்கும். பட் வி ஹாவ் டு லிசன் கேர்ஃபுல்லி. ஓகே. Okay. We start the class because we know what is computer. Um, could you please tell me what is computer? Because majority are from IT background, so you know very well about computer. So what computer does actually? Hello. So you know computer is a electronic device. So if you give any input, it gives us it gives a result. So, a device, computer is a device that makes our work easy. So there is no need to work difficult. So if you give input, it gives us output. You might have working on different platforms. According to the platform, majority of them may work in automation field. So they may use automation code and SQL Server within 5 to 20 seconds it gives us result, so it makes us easy. Okay, computer is right that helps us to complete our task easily and speedily. If you give input, it processes using central processing unit and gives us result. This is a gentle definition of computer. So what is a software? So software is a set of instruction which gives instruction to the computer and what to do, when to do, and how to do. So if you give instruction, it performs some task and gives us input. So these are the example. What are the example? Paint. So if you click any symbol, any icon which is in the paint, so you are instructing computer to draw a picture, or you have to write text. So we are giving instruction to the computer, and WhatsApp, through WhatsApp web we can connect and we can send message and games and other application. So all everything is written in a particular language. You are giving instruction. If you want to save, we have to go to file and save. This is instruction you are giving to the computer. It does what we have to do. If we want, we can delete. If we want, we can restore the contents. So these are the example. And next title is data representation. So I mean computer can understand only zeros and ones, and you know already. So digits. So its information in computer represent by variable that may be represented in limited number of discrete values. So decimal digits start from 0 and ends with 9. So decimal computer have only two states. It may be true or false or yes or no. So computer can understand only zeros and one. Okay, zeros and one is known as digits. So digital computer is binary number system which has two digits, one zeros and ones. Okay, if you type hello welcome, okay, it will be converted into zeros and ones which computer can understand. Now what is bit? A binary digits is called bit. Next is computer system level architecture. These are the general introduction. So first level is digital digital circuits which has circuits and gates. Level 1 is control which has microcode. Level 2 is consists of machine. We have to give set of instruction set. And level 3 is system structure, operating system, assembly language, assembly code. We have to write assembly code. Next is high level language. These are the examples: C++, Java, and other softwares are there. And level 6 is user executable program. These are the computer level architecture. So now what is computer architecture? So computer architecture describe the computer, what the computer does. Actually, we are not giving set of instruction to the computer, but the architecture describes what the computer does, because we don't know. We can dismantle all the CPU parts, but we cannot see what is working inside the computer. So computer architecture describes what the computer does. Now, what is computer organization? It describes about how does it work. So, do you know the difference between computer architecture and organization? Computer architecture describes about what the computer does. Organization describes how it does. Okay. Now, what are the difference between computer architecture and computer organization that we have to know? Okay, as I told you earlier, describes, so computer architecture describes what the computer does, and the computer organization describes how it does, because we have to know how the computer works. Next is deals with functional behavior of the computer system, and it deals with structural relationship. Third is because from the computer level architecture, computer level architecture, we can easily know it's clear deals with high level design issues, because we are using high level languages like C++, Java, and other language we can use that clearly deals with design issues. And this is lower level. Here we are using lower level design issues. Here we are using high level design issues. I mean, assembly language programs will use here. Here, high level language program will use. And if there is any problem outside, we can sort out the problems. Next, architecture indicates its hardware, but organization indicates its performance. Uh, these are the difference you can easily read. I've just given what to say, the difference between computer architecture and organization. Next, black diagram of digital computer. Digital computer consists of random access memory, control processing unit. Control processing is used to perform arithmetic and logical functions. So if you give input, it processes through central processing unit and gives us desired output. Okay. Okay. Now from the picture we can from the picture I'll explain you one by one what is RAM. You know what RAM is: a random access memory which can access any location in the memory. So retrieve binary information with the fixed interval time. So all the information is saved in the memory. We can retrieve all the information only from RAM, not from ROM. So input output processing, which contains electronic circuit for communication. Okay, if you give an input which can communicate only through the electronic circuits, so which can be used for communicating and controlling the transfer of information between the computer and the outside world. So outside the world means we are giving input to the computer and processes using central processing unit and gives us real output. So input-output devices or connected to the computer includes keyboards, printers, terminals, magnetic disk drives, and other communication devices. If we have these many things, then we can work out. So next one is number conversion. Number conversion is for the classified into binary conversion, decimal conversion, octal conversion, and hexadecimal conversion. So under binary conversion, so we can convert from binary to decimal, binary to octal, binary to hexadecimal, and decimal conversion consists of decimal to binary, decimal to octal, decimal to hexadecimal, octal further classified into octal to binary, octal decimal, octal to hexadecimal. So we can convert into these forms: hexadecimal, hexadecimal to binary, decimal, and hexadecimal to octal. So this is how they have classified. Now I'm going to explain one by one. So now we have to understand the base of these conversion. So one is, so these are the representation: binary representation, octal representation, decimal, and hexadecimal. These are the base we have to remember. So binary base is 2, octal base is 8, so decimal base is 10, hexadecimal base is 16. See, binary octal starts from 0 and ends with 7. So decimal starts with 0 and ends with 9. And hexadecimal start with 0 and end with 15. Okay. And 10, 11, 12 are represented 8. 0 to 9. Up to 9 we can write number. After 10, if there is 10, we have to mentioned in A, B, C, D that we can discuss later. So see, decimal 0 to 15. So hexadecimal, how we have to represent? So up to 0 to 19, we can write as it is. So A represents 10, B represents 11, C represents 12, 13 represents D, 14 represents E, and 15 represents, I mean, F represents 15. See how we have to remember the binary codes. Okay, I tell you easy way to remember binary codes. See how many hexadecimal, what is the hexadecimal base? Could you please anyone tell me? What is the base of hexadecimal? 16, right? See, the hexadecimal base is 16. So the number starts from 0 and end with 15. So total how many numbers are there? 16 numbers are there. So we have to remember binary codes, then only we can convert any number in a binary format. So I'll tell you one easiest way to remember binary codes. There is no need to by heart all these binary codes. See, 0 to 7. So how many numbers are there? 0 to 7, 8, right? So we can divide from 0 to 7 and 8 to 15 off. See, first 8 digits. First 8 digits, put 0. I'm talking about the first line. I'm talking about the first line to remember binary codes. First, we have to write 8 zeros and 8 ones. Is it clear?
Yes, sir.
Okay. Because base of hexadecimal is 16. We have to remember equivalent binary code. So first 8 hexadecimal, we have to write 8 zeros and 8 ones. Then second row. Now we have to, what we have to do is, first we have to write 4 zeros and 4 ones. Again 4 zeros, 4 ones. Is it clear? Second line, how we have to write is 8 zeros, 8 ones. Second line, 4 zeros, 4 ones. Third line, 2 zeros, 2 ones. 2 zeros, 2 ones. Third line, 0 1 0 1 0 1 0 1. If you write like this, it will be easier to understand and easy to remember. There is no need to by heart all the binary codes. Okay, now do you understand how to write binary codes?
Yes, sir.
Okay, I repeat it once again. இங்கே பாருங்க டோட்டலாக வந்து 16 ஹெக்ஸாடெசிமல் பேஸ், ஹெக்ஸாடெசிமலோட பேஸு 16. ஓகேவா? ஃபர்ஸ்ட் என்ன பண்ணணும் அப்படின்னா, ஃபர்ஸ்ட் டிவைட் திஸ் இன்டு ஆஃப். ஃபர்ஸ்ட் ஆஃபுக்கு ஃபர்ஸ்ட் ரோவில் இங்கே பாருங்க 8 ஜீரோஸ் போட்டுக்குங்க. செகண்ட் ஆஃபுக்கு 8 ஒன்ஸ். ஓகே, ஃபர்ஸ்ட் ரோவில் ஃபர்ஸ்ட் ஆஃப்க்கு 8 ஜீரோ, அதுக்கப்புறம் 8 ஒன்ஸ். செகண்ட் ரோவில் இது என்ன பண்ணும், இது பாதியாக டிவைட் பண்ணும். ஃபஸ்ட்டு 4 zeros 4 1, again 4 zeros 4 ones. Next third line la 2 zeros 2 ones, 2 zeros 2 ones, 2 zeros 2 ones. Last line la வந்து 0 1 0 1 0 1. Okay, if you write like this, it is easy to remember. Okay, no, it is much difficult to understand. If you feel like this, how we have to write is, see, 0 1. This is how you have to remember the binary codes. 0 1, then 10 11. See, 1 10 11, then 0 1 10 11, 0 1 10 11. In this method we have to remember. So if we remember in this format, we may make lots of mistakes. So only for this reason I told you to follow 8 zeros 8 1, 4 zeros 4 1, 2 zeros 2 1, 0 1 0 1. If you write in this way, is it easy to remember? Okay. because using binary codes we are going to solve binary conversion. So first one is binary numbers and the systems. So binary conversion, we can say binary conversion. First how we have to convert binary to decimal. So this is binary numbers. What is the base of binary? Binary base is 2, decimal base is 10. So we have to convert binary number into decimal number. Okay. First, this is a simple example. So 10110001 base 2. See how many numbers are there? Okay. See totally how many numbers are there? 5, right? So this is zeroth position, this is first position, this is second, and this third position, and this is fourth. Okay, minus 1, minus 2, minus 3. See, base is 2, base is 2. This is zeroth position, 1, 2, 3, 4. So how we have to write this position? How we have to write as 2 power 0. What is that? 0 into 2 power 0. Then how we have to write? Plus 1 into 2 power 1 plus 1 into 2 power 2, 0 into 2 power 3, 1 into 2 power 4. See, I have written in this way. So number starts from here it is. So 0, 1, 2, 3, 4, 1 into 2 power 4, 0 into 2 power 3, 1 into 2 power 2, plus 1 into 2 power 1, 0 into 2 power 0. Is it clear up to this? Is there any doubt? Hello?
No, sir.
Yes, sir.
Okay. So there is no need to worry about this part because it will come in minus fractional part. Okay, it will be difficult to calculate. So neglect this part. Okay. Okay, if you are good in maths, you can calculate. Okay, because only using the positive value we can find out the result. So next we have to calculate 2 power 4. So 2 power 4 is 16, 2 power 3 is 8, and 2 power 2 is 4, and 2 power 1 is 1, and anything power 0, 1. Okay, even it may be 9 power 0, 8 power 0, or 5 power 0. Anything power 0 is 1. So don't worry about the fractional part. I'm talking about the positive parts. So 2 power 4. If you multiply 1 into 16, what's the answer? 16. If you multiply any value, so it becomes 0. So this part and this part becomes 0. Okay, 0 into 8, 0, and 1 into 4, 4, and 1 into 2, 2, and others are 0. Don't worry about the negative fractional part. So we can take up to this. Okay, if you add these values, so 16, 4, 20, 0. If we add up to this, we'll get 22. Don't worry about the fractional. We can add directly. So what is the base? Base is 10. So what they are telling is we have to convert from binary to decimal. What is the base? Base is 2. And what is the base of decimal? 10. So we have converted from binary to decimal. This is how we have to convert. Clear? So next, we move to binary to octal. So what is the base of octal? So binary is 2 and octal is 8. So these are the binary numbers. So how we have to convert from binary to hexadecimal? I tell you, first we have to make pair of 3 bits. So how we have to make from here? We have to take, so divide. See, what we have to do is we have to divide into 3 pairs. Is it clear? This is how they have divided. Okay, we have to make pairs of 3 bits on both sides. It may be positive or fractional side. We have to make pairs of 3 bits. So this is how they have divided. So next is, so what we have to, what is the rule? Hexadecimal is 8 bit. So this is 1, 2, 4, 8 in the sense. So we have to add 3 zeros. If it is one number, we have to add 2 zeros. See, here only one number is there, so we have to add 2 zeros. Okay, we have added 2 zeros additionally. Then write equivalent number. So 777. So 111. Now you go to the binary numbers. So 111, where it is? 111. 111 is 7. So write 7. So next one is 110, where it is 11110, 6. So 6. 101, 1015. Okay, 001. So 1, 1 double zeros, 100, where it is 4. So 765.114. The answer is, here it is. Is it clear? So how we have to convert? If it is binary to hexadecimal, first we have to make 3 pairs and write equivalent binary numbers. This is the answer. Binary to octal. Any doubt?
Sir, once again, can you explain?
Is there anyone from other states who cannot understand Tamil? So let me explain once again.
எல்லாருமே தமிழ் தான் சார்.
ஓகே, ஸோ இப்போ இங்கே பாருங்க, இது பைனரி நம்பர்ஸா? ஸோ இந்த நம்பர் எது வேணாலும் இருக்கலாம். ஓகேவா? ஸோ பைனரி அப்படின்னால அதோட பேஸ் வந்து 2. ஸோ ஆக்டல்னா அதோட பேஸ் வந்து 8. ஸோ ஃபஸ்ட்டு என்ன பண்ணணும், இந்த மாதிரி எந்த நம்பர் பைனரி நம்பர் வேணாலும் கொடுத்துருக்கலாம். நம்ம என்ன பண்ணணும், அவங்க என்ன சொல்கிறாங்க, ஆக்டல் அப்படின்னா 3 பிட்ஸாக நம்ம என்ன பண்ணணும், அதை செப்பரேட்டாக டிவைட் பண்ணி வச்சுங்க. அது எப்படி ஸ்டார்ட் ஆகணும், இங்கேருந்து வரணுமா அப்படிலாம் கிடையாது, இங்கேருந்து தான் போகணும், லெஃப்ட் டு ரைட் தான் போகணும். ஸோ இங்கே என்ன பண்ணுங்கள், ஃபஸ்ட்டு நம்ம எப்படி டிவைட் பண்ணியிருக்கோம், இந்த பார்ட், எந்த பார்ட்டு, இந்த ஃபஸ்ட்டு 3 நம்பர்ஸ் இதை இங்கே போட்டிருக்கோம் பாருங்க, இங்கே இருக்கா, ஃபஸ்ட்டு இந்த 3 நம்பர்ஸ், இந்த 3 பேராக நீங்கள் இது மாதிரி பண்ணி வச்சுருங்க. சப்போஸ் லாஸ்ட்டில் ஒரு நம்பர் மட்டும் இருக்குது, 0 மட்டும் இருக்குது, அதுக்கப்புறம் வேறு எதுவுமே இல்லை அப்படின்னா 0 0 ஆட் பண்ணிக்கலாம். ஓகேவா? இல்லை 1 இருக்குது, இன்னொரு நம்பர் இல்லை அப்படின்னா, ஏன்னா 3 பேராக தான் இருக்கணும், சப்போஸ் இல்லை அப்படின்னா இல்லாத பேருக்கெலாம் கண்டிப்பாக 0 0 ஆட் பண்ணுங்கள். அப்போ என்னென்னா இது 0 0 1, இங்கே பாருங்கள், இதில் வந்து இங்கே என்ன இருக்குது, 0 0 1 இருக்குது. அப்போ 0 0 1 ஒரு பேராகவும் 1 மட்டும் தனியாக நிற்கிது. அப்போ என்ன பண்ணணும், இது கூட 2 0 ஆட் பண்ணிக்கேன். ஸோ 2 0 ஆட் பண்ணியாச்சா? இப்போ என்ன பண்ணணும், இதுக்கு எல்லாமே ஈக்குவலண்ட் நம்பர் நம்ம கண்டுபிடிக்கணும். ஸோ அதுக்கு என்ன பண்ணணும், ஆல்ரெடி பைனரி நம்பர் நம்மளுக்கு டேபிள் இருக்குது, இங்கே இருக்கா, இந்த டேபிளில் பாருங்கள், இது வந்து 16 டிஜிட் இருந்தால் தான் இந்த 4 இதுவுமே எடுத்துக்கணும். நம்ம ஃபஸ்ட்டு 8 ஆக்டல்னால் 3 நம்பர் மட்டும் தான் பார்க்கணும், இதில் லாஸ்ட் 3 டிஜிட் மட்டும் தான் நம்ம பார்க்கணும். இங்கே பாருங்கள், இதில் 111 அப்படின்னு இருக்குது. 111 எங்கே இருக்குது, இங்கே பாருங்கள், இங்கே 0, இந்த லாஸ்ட் 3 டிஜிட் மட்டும் தான் பார்க்கணும். 111 எங்களுக்கு 111க்கு நேராக 7 இருக்கா? Saraswati, unmute your mic. If there is any doubt, you can ask me. Otherwise, unmute your mic and listen carefully. So 111க்கு நேராக என்ன இருக்குது, 7 இருக்குது. ஸோ ஸ்ட்ரைட்டாக நம்ம என்ன பண்ணோம், 7 போட்டுட்டோம். அடுத்து 110 இருக்குது. ஸோ 110 எங்கே இருக்குது, இங்கே பாருங்கள், 110 ஈக்குவலண்ட் hexadecimal number is 6. So decimal number is 6. So what is the next number, 101. So 101 equivalent decimal number is 5. So அதுக்கப்புறம் 001. So 00001. Here it is. Equal number is 1. Saraswati, don't talk personal things in this group. If you are doing the same thing, I'll remove from the group. So you have to follow the rules and regulation of the university. So is there any doubt? Is it clear?
Sir,
Yes, Anita?
011 we should not take it. We should not take a
011. What you're talking about?
that 111, 110,
Yeah.
101 and 011. It's there, no sir. We should not
Yes.
take that. It's a
No.
value of 3.
So first we have to make 3 pads.
Okay.
Okay, what is the rule? See, I have given rule as if you want to convert from binary
Binary
to octal, the base of binary is 2, octal base is 8. So if you want to convert anything from any conversion from octal, first we have to do what we have to do is make pairs of 3 bits. This is the first rule. Okay, first rule. It may
Okay,
be
sir.
see, in right hand side only one bit is there. If it is like this, we have to add zeros. See here, 2 1s are there, so we have to make three pairs. So what we have to do is we can add zeros.
0.
Okay, got it?
Yes, sir.
So we have made three pairs of bit. So now we have to find out equivalent binary numbers. So last three digits we have to see. How do we find equal numbers? So we have already seen in the table. So last three digits we have to see. So 777 equivalent binary number is 777. The equivalent decimal number is 7. Got it?
Okay, sir. Got it. Thank you.
So equivalent binary number is 7. So 1106. So this is how we have to read. 5. This is 5. This is 3. So this is the answer. So if you understand the binary tables, so it is easy to answer any kind of questions. See, the answer is 7653.
Okay, sir.
Next is binary to hexadecimal. Now the rule is changed. How the rule is changed? Here we have to make pairs of 4 digits, 4 bits, not 3. If it is octal, make pairs of 3 digits. If it is hexadecimal, make the pairs of 4 bits. See, now you are going to answer my questions. Not only Anita and others can answer. See, now I have make pairs of 3. Now you convert these things from 3 pairs to uh, uh, 4 bits and tell me the answer. See, they take the same number, 11 11 0 1 0 1 0 11 dot 00 11. See, what is the rule? If you want to convert from binary to hexadecimal, make 4 pairs of bit.
Sir, I want the table, sir.
Just a minute.
Yeah.
See, first, what we have to do, make 4 pairs of bits. Okay. Here only 3 pairs of bits are there. What we have to do? Either we have to add 0 or 1.
0. 0.
Okay. See, I have added 0. Now tell me the equivalent decimal number. So I show you the table. From the table, you have to tell me the exact answer. Okay, this is the table. Look at the table and tell me the answer.
Seven. 7.
Okay, here it is. I need complete answer.
FAB,
7,
sir.
8, sir. Dot. Sir.
Yes, Anita, you tell me the exact answer.
Sir,
Then
I have a question I have a doubt in question. In the first one, five ones are there. You have written only 4 ones here.
where it is 5 ones
In a black color.
with this one.
Yes.
Okay, that is okay, no problem. So write it is double.
FAB.3.
Okay. What about this?
FAB.3.
0011. What about this?
7AB.3.
Okay. Okay. Then okay, answer is correct. Okay, 7AB.3 base 16 because we have to convert. Anita, can you unmute Karthik because I am hearing only noise from you. So now you know how to convert from binary to octal and binary to hexadecimal. Okay, is there any doubt?
No, sir.
Okay,
No,
now
sir.
okay, we are going to decimal conversion. So what is the base of decimal? 10. So decimal to binary. So this is decimal number 152.25 base 10. So first what we have to do is we have to divide 150 by 2 because we are going to convert from decimal to binary. So this is decimal number. We have to convert to binary. So what is the base of binary? Binary is 2. So what you have to do is you have to divide 150 to 152 by 2. What is the answer if you divide 152 by 2? What is the answer?
76.
Okay. Is there any reminder?
Zero, sir.
Okay. So here we have to write 0. Then if you divide 76 by 2, what is the answer?
38.
38. Is there any reminder?
Zero.
Okay. Next, if you divide 38 by 2, what is the answer?
19.
Reminder?
Zero.
Okay, next.
9 times.
Then
Remainder will be 1.
9. Reminder is 1.
1.
Next.
4 times.
Okay.
Remainder will be 1.
Mm.
So 2 times and remainder will be 0.
0.
Mm.
Next is 1.
1 time and remainder is 0.
Okay. Now how we have converted from this is decimal number and this is binary number. So how we have to do right here is 1
One,
0 1
one,
0 double 1 triple 0. This is LSB. LSB in the sense least significant bit. Okay. This is known as MSB. MSB, most significant bit. So the answer is 10110000. See now we have to check. See if you divide 152 by 2, so quotient and 76, there is no remainder. So what is the final answer? So answer is 100011000. 1001000. The answer is correct. So what is the base? Base is 2. Is it clear? Because we have converted from decimal to binary. So if it is fractional part, what we have to do is we have to divide the fraction number into 2. If you divide 0.25 into 2, we'll get 0.50. Again, we have to divide. So we have to multiply the, from the result 0.50 into 2. So we'll get the carry is 1, result is 0. Okay, now the answer is 0.1. Clear? Now decimal to octal. What you have to do is, if it is octal, what is the base of octal? Octal base is 8. So 152. You take the same number and tell me the answer. Take the same number. The number is 152 divided by 8. Okay, if you divide 152, you can divide 152 19 times. There is no reminder. Then if you divide 19 by 8, so 2 times, remainder 3. And if you divide 8, uh, there is no remainder. I mean, there is no quotient. Remainder will be 2 because we cannot divide. Because this is smaller, this is bigger. So write the number 230 basis 8. Clear? Shall we move to the next problem?
Okay, sir.
Okay, next step is fractional. As it is, we have to divide. If it is fractional uh, part, we have to divide using the particular conversion method. So next is decimal to hexadecimal. So base is 10, decimal, hexadecimal base is 16. We have to divide 150 by the base is hexadecimal base 16. So remainder is 9. Uh, then again we have to divide 9 by 16. 16, 9 is not divisible by 16. So remainder is 9. So 98 will be the answer. So next step, if it is fractional, we have to divide the given number into 16, then we'll get the answer. Next is octal conversion. So you know the equivalent octal number. So 0, if it is 0, I have taken only last 3 digits number. It is 0, 0, then 1, 10, 11, 100, 101, 110, 111. So these are the equivalent binary numbers. So hexadecimal to decimal conversion. So this is a number. Now we have to convert from octal to decimal. So what is the number? 152.28. There is no need to worry about the fractional part, because if you get the same answer 106, you can straight away take this answer. It will be correct. So it should be 106. So again, what we have to do is it has to multiply from this left to right direction 2, where it is. So how many numbers are there? Only 3. The base starts from 0. So totally 3 numbers are there. So 0, 1, 2. So 1 into base is 8, 8 power 2. Then next number is 5, 5 into 8 power 1, 2 into 8 power 0. Anything power 0, 1. Okay. uh, 8 into 8, 64. 5 8s are 40. So anything power 0 is 1. So 2 into 1, 2. If you add these three values, the answer is 106. There is no need to worry about this fraction part. Next is octal to binary. So octal base is 8. So what we have to do is, so if you look at the number, you can easily tell me the answer. So anyone can explain me how did we get this answer? Anita, Lokesh.
From each, shall I tell, sir?
Ah, yes, you can tell
Yeah.
me.
For each and every digit, the binary form in the table it's there, no, sir. For 2, for example, it will be 010, and
Okay.
then for 5, it will be 101, and then for 1, it will be 001.
Yes, Divya Priya, is it correct? Good. See, for equivalent binary numbers, we have to write equivalent binary numbers of this actual number. So we have to convert from actual binary. So one is, what is the equivalent number of 1,001? Next 5. So we have to make 3 pairs of bits. So 1, 5, 101 is equivalent binary numbers, and 2, 010. And again, we have to follow the same rule and we have to write base. So this we have to keep in mind. Octal base is 8, binary base is 2. This is the answer. Next, next question you can easily answer. Octal to hexadecimal. We have to make 3 pairs. So octal first, we have to write 3 pairs of bits, then make it as 4, then tell me the answer. Anyone can tell me or shall I explain? See, the octal base is 8, hexadecimal base is 16. So we have written equivalent binary numbers here. So this, because we have converted from binary numbers, octal numbers to binary. So now we have to convert the binary numbers into hexadecimal number. What method we have to follow? We have to make four pairs of bits. So four pairs of bit. The numbers are, see, four pairs. 101. This is one pair. Here I have written here. Next pair is 0 double 10. Next pair I have written here. So 0 stand alone. Next, this part. We have to make pairs from left to right, not right to left. Okay. We have to write from right to left, this way, left to right, right to left. Here, how we have to make right to left. Here we have to move from this direction, and here we have to move from this direction. So have make four pairs of bits and zero ones. Last, if it is one number or two numbers, we have to add zeros on both sides. So if it is hexadecimal, we have to make four pairs of bits. So here I have added 0 1 is there, so I have added two zeros. Here only 1 0 is there, so I have added three zeros. So
Shall I say the answer, sir?
yes, you can.
068 point dot 54.
Okay, 0a.
68.
Okay, 6a.54 base
54
16.
base 16.
Okay, so the now hexadecimal conversion, the equivalent hexadecimal number. So I have written here, if it is 10, so we should not write as 10. Instead of, we have to write equivalent binary numbers. So if it is A, we have to write 1010. If it is F, 1111 is the equivalent binary numbers. So now we have to convert from hexadecimal to decimal. So this is decimal number. Can you tell me the answer for this question? 152A point 525 base 16. See, I have written all the steps, but you have to tell me the exact answer for this question.
Sir, this time hexadecimal changed to decimal. Okay, decimal hexadecimal base 16.
Karthik,
So fourth is
no.
yes, sir.
What I'm see, I have written all the calculation. What I'm telling is, I need the final answer of this question. So if you look at the problem, you can easily find out the answer. So work out. Don't worry about the fractional part, 0.25 base 16. So calculate up to this and tell me the answer.
5418, sir.
Okay, correct. Okay, what about other students? Is there any doubt in this problem? See, how many numbers are there? Four. So number starts from 0, ends with 3. So 1 into, what is the base of hexadecimal is 16. So 1 into 16 power 3. Then second number is 5. 5 into 16 power 2 plus 2 into 16 power 1 is nothing but 10. So anything power 0 is 1. It may be any numbers. If it is 0, the power is 0, that we have to consider as 1. So anything power 0 is 1. So 10 into a, how we have to write the equivalent hexadecimal number, binary number is 10. Decimal number is 10. So 10 into 1, 10. So 2 into 16, 32. 5 into 2, 56. 1280. 1 into 4096, the same number. If you add these four numbers, you'll get 500418. Okay, this is the exact answer. There's no need to worry about the fractional numbers. The next one is hexadecimal to binary. So hexadecimal to binary. What we have to do is, we have to write equivalent binary numbers for the hexadecimal number. Got it? 1 triple zero 1, 5 s 0101, then 2 0010, 1010 for A, point 2 is, you know already the number 0010, 1 is 0101 base 2. Is it clear?
Yes,
So
sir.
if
Yes, sir.
okay, if you know the hexadecimal and equivalent binary codes, is it easy to solve these kinds of problems? Then hexadecimal to octal. Now tell me the exact answer for this question. Hexadecimal to octal. So hexadecimal is we have to make 4 pairs of bits. If it is octal, we have to make 3 pairs of bits. Now tell me the exact answer for this question. So first step, make 4 pairs of bits. So we have written equivalent binary codes. This is the first step. Then second step, what we have to do is we
One-
have, if you
12452, sir.
I didn't get you. If you
12452 will be the whole part, whole number.
yes,
Yeah.
152A. See, if it is hexadecimal, see, I'll explain once again. This is the hexadecimal number. We have to convert from hexadecimal to uh, octal. So what I have done here is have written equivalent binary numbers. Yes. So the equivalent binary number of 1 is 0001. The equal binary number of 5 0 and 0 0101. So in this way I have written binary numbers. So next what we have to do is, so if you want convert, so if it is 4 pairs of bit, what is it? Hexadecimal numbers, right? If it is 4 pairs of bits, it is hexadecimal number. From hexadecimal number we have to convert as octal number. If it is octal number, what we have to do, we have to make 3 bits. Okay, make it as 3 and write equivalent number. 001 is 1, 010 is 2, 100 is 4, 101 is 5, so 010 is 2. This is the answer. Okay, any doubt? Shall I repeat the question once again, or you get my point? ஓகே, மீதி இருக்கிறவங்களாம் புரியுதா? டவுட் இருந்தால் கேளுங்க. இதை ஒர்க் அவுட் பண்ணி பார்த்தா தான் புரியும். இஃப் யூ டோன்ட் ஒர்க் அவுட், you will get lots of confusion because we are converting. We have seen many conversion. Okay, next, logic gates. So what does it mean by gates? Okay, gates is a manipulation of binary information because we can give 2 inputs or 3 inputs. Everything can be done only through binary information using logic circuits. So truth table, we have to understand, we have to give input. According to the input, we'll get the output. So which can be represented in gate. So these are the standard tables. And so and in the sense multiplication. So we are giving 2 inputs. So the symbol is and the symbol is we have to draw like this. So here we are giving 2 inputs and we'll get the output. Here the inputs are 0011, so 0101. What is the rule here is, if we multiply any same number, we'll get the answer. If you multiply 0 into 0, we'll get 0. 0 into 1, 0. 1 into 0, 0. 1 into 1, 1. So final answer is, if you multiply, both inputs are same, the output is same. Okay, that should be, if it is 1, true, 0 stands for false, 1 stands for 1. Is it clear? We have to multiply. Next, OR gate. The symbol will be like this. We have to add. So if we add 0 plus 0, we'll get the answer 0. 0 plus 1, 1. 1 plus 0, 1. 1 plus 1, not 2. Okay, 1 plus 1, 1. 1 carries. Okay, clear? Here this is multiply. We have to multiply value of A and B. Here we have to add. Next is inverter. This opposite. If you give 0, we'll get 1. If you give 1 as input, we'll get 0 as output. This is the inverter. Or in other words, we can say it's as NOT gate. Then buffer. Buffer, the same output. If you give 0, you'll get the same output. If you give 1, you'll get the same output. Next is NAND gate. This is the opposite of AND. This is opposite result of AND gate. NOR gate is nothing but opposite result of OR gate. See what is the output of AND gate? 0 0 0 will get here 1. See, we are giving A, B as input, and we have to do we have to complicate the result. Complicate the result. NAND gate. What? See, as I explained you, AND gate or AND gate truth table once again. So what you are getting? If it is A and B or 1, will get 1. Okay, any input. See, if it is true, both inputs are true, the output is true. If any one of the input is false or both inputs are false, we'll get the output as false. If A and B values are true, the output is true. Here the output is opposite of AND gate. Okay. If two inputs are true, the output is false. If any one of the input is true or both inputs are false, we'll get answer is true. Is it clear?
Yes, sir. Yes, sir.
அதாவது என்னன்னா AND கேட்டுக்கு ஆப்போசிட் வேல்யூ. அதில் என்ன அப்படின்னா ஏபி அந்த ரெண்டு வேல்யூயும் ட்ரூவாக இருக்கும். ட்ரூ இந்த சென்ஸ் 1 1 1 1 அப்படி இருந்துச்சுன்னா அவுட்புட் வந்து 1. ரெண்டு வேல்யூவும் ட்ரூவாக இருந்தாலும் இல்லை நம்ம கொடுக்குற இன்புட்டில் ஏதாச்சும் ஒரு வேல்யூ ட்ரூ ஆர் ஃபால்ஸாக இருந்தாலும் அதோட அவுட்புட் வந்து ஃபால்ஸ் தான். ஓகே, அப்போ இங்கே என்ன பண்ணுறோம்? ரெண்டு இன்புட்டு ட்ரூவாக இருந்துச்சுன்னா அவுட்புட் வந்து ஃபால்ஸு. ஓகே, ரெண்டு இன்புட்டு ஃபால்ஸாக இருந்தும் இல்லை ஏதாச்சும் ஒரு இன்புட்டு ஃபால்ஸாக இருந்தாலும் நமக்கு அவுட்புட் வந்து ட்ரூ. ஓகேவா? அதுக்கப்புறம் நெக்ஸ்ட்டு நார் கேட். இது வந்து ஆப்போசிட் ரிசல்ட் ஆஃப் ஆர் கேட். Here what we have to do is we have to add the values. So if you add 0 plus 0, see AB is nothing but input we are giving to the NOR gate. Suppose here for A we are giving 0, for B we are giving 0. If you add 0 plus 0, what is the value? 0. A plus 0 plus 0, the value is 0. So we have to complement the value. So output வந்து 0 இருந்துச்சுன்னா என்ன பண்ணணும்? நம்ம 1 மாற்றணும். So if you
1.
add 0 plus 1, what is the answer? 1. Actual value is 1. But we have to complement the values of A and B. The output is 0. You got this answer? Did you get my point? Is there any doubt in NAND gate and NOR gate? And next is exclusive OR. Then we have to follow in this way. We have to complement A's value, B plus then B's complement. If you do this, if you follow this formula, we'll get this output. Okay, if both inputs are same, the output is false. Any one of the input is true, the output is true. Okay, next is opposite of exclusive NOR is opposite or opposite of exclusive NOR. See, if both inputs are same, output is true. If any one of the input is true, output is false. That's all. Next is complements. One's complement. Say for an example, the given number is 0 1 1 1. Okay, now we have to convert 0 into 1, 1 into 0. See, what is the value of one's complement? So 0 1 1 0. What is the first step? See, in one's complement, we have to transfer the bit 0 bit to 1 and the 1 bit to 0. That's first rule. 0 இருந்துச்சுன்னா 1 1 இருந்தா 0. இப்போ என்ன பண்ணணும்? இதை நம்ம என்ன
One double zero one.
Okay, 1 0 0
One.
1. So we have converted one's complement.
One complement.
Okay, now I have to change one's complement into two's complement. What we have to do is we have to add 1. So if you add 1 plus 1 1, the
One.
answer is 0. No.
Sorry.
Next, carry 1, carry is 1. So if you add 1 plus 0, the answer is 1, and the same answer comes down. Okay, this is the answer. Is it clear? Any doubt? Okay, I'll repeat the question once again. So the given number is 0 1 1. So what is the rule? If you want to convert in once,
0 to
once
1 and 1 to 0.
This is the first rule. So we have to
One.
convert 0 into 1, 1 into 0. Now we have converted into one's complement. Okay, if we want to convert from one's complement to two's complement, what we have to do? We
One.
have to add
Add
1.
1.
Okay, add and tell me the answer. 1 0
0
0
0 0 1.
1
One.
plus. Okay, this is two's complement. This is two's complement, and this is one's
One's
complement.
complement.
Is it clear? Okay, that's all. See, if you want to convert from one's complement, we have to add. So two's complement of binary number is 1. Add it to the one's complement of the binary number. See, I have converted from one's complement to two's complement 0 1 1. And then again we have to add 1 under and we'll get the answer. So there is no problem, you can easily understand. First, what we have to do is we have to convert from the given number into one's complement and add 1 and we'll get the answer. This is how we have to convert from one's complement to two's complement. But we have to follow the rules. 0 into 1, 1 into 2, then add 1, we'll get the answer. Next is 9's complement. This is also easy. So it may be 1 digits, 2 digits, 3 digits, or 4 digits. It may be. There is no need to worry about this. So 9's complement can be obtained by subtracting every digit of a number by 9. Say for an example, the given number is 7. So given number is 7. If it is 9's complement, you have to subtract from the given number. So answer is 2, right? If you subtract 7 from 9, you will get this. Suppose it's 2-digit number, 90. So we have to subtract by 9's complement. If it is 1 complement, we have to use only 1 digit. If it is 2 digit, we have to use 2 digit. If you subtract, the answer is what? 9. If it is 3 digit, 500. We
Triple
have to
nine.
subtract 999. What is the answer?
499.
Okay. So 2, 9, 499 or 9's complement. If you want to convert from 9's complement into 10's complement, what we have to use? Again, we have to follow the same rule. We have to add 1 and the answer is 500. So if you add from the given value, it is known as 10's complement. Is it clear?
Yes, sir.
Okay, the given number may be 1 digit, 2 digit, or 3 digit. If it is 3 digit, according to the digit, we can add 9's and subtract from the given value and get 9's complement. If you want to convert from 9's complement to 1's complement, we have to add 1, then it converts into
10.
10's complement. Okay, here they have given the story. So if you subtract 9 from 6, you will get 3. 99 minus 27. So 72, 999 minus 2, 33, 7, 65. So 327, 372, 234, 672 or 9's complement of the given numbers. So 10's complement, we have to add 1. See, the answer is if you subtract 7 from 9, we'll get 2. If you add 1 from the given output, it becomes 9's complement. Okay, is there any doubt? 1's complement, 2's complement, 9's complement, 10's complement, and the conversion method. Okay, next is fixed point. If it is single precision, double precision, base is 2, sin is 1, exponent 8. Here the double precision exponent is 11, significant 23 plus 1, 52 plus 1. These are the fixed point and floating point representation that we have to keep in mind. So next is op precision are there. This 16-bit, 1 sign bit, 15 5-bit exponent, 10-bit mantissa. Single precision that we already know 1, 8, 23. Then if it is double precision 64-bit, 1 bit for sign, 11 bit for bit exponent, and 52 bit for mantissa. And quadruple precision 128-bit, 1 bit for sign bit, 15, and 112 bit for mantissa. So these are the fixed points for the precisions. Next is other binary codes. So binary code you have already know. Okay, can anyone tell me what is the equivalent binary code for 15? What is the equivalent binary code for 15?
4 1, sir.
Okay.
4.
And the equivalent hexadecimal number?
16.
Sir,
No.
F,
F.
F, F.
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 Okay. Now other binary codes. So encoding numbers, letters, and words can be represented using a specific symbols, and letter and words can be coded. See, the digit starts from 0 to 9, then uh, words, letters. What are the letters? Starts from A to F. So it can be other binary codes can be represented using letters and words. Got it? Next is a group of symbol is called code. What is code? Group of symbols. So digital data is represented and it can be stored, and it can be transferred as a group of binary bits. This is called binary codes. So what is code? group of symbols. If it is binary code, the digital data is represented that can be stored and then that can be transferred as a single binary bits or group of binary bits. This group is known as binary codes. So it has certain advantages. One is it is suitable for computer application and it is suitable for digital communication. And since only 0 and 1 are being used because computer can understand only zeros and ones and implementation becomes easy for the computer. And classification of binary codes and weighted codes, non-weighted codes. I mean, the binary codes is further classified into weighted codes, non-weighted, binary coded decimal, alphanumeric codes, error reduction codes, error correction codes. So what is weighted codes? If it is weighted code, we have to give weight to the binary numbers. I'll explain it through a simple example. So this is decimal value is 24. So the position weight score. So what it is 8421. So if it is four numbers, we have to write in this form. So where it is, so 2 is there. We have to divide into two parts. So here 1, 2, 4, 8. So where is 2? So if it is there, if the particular number is there, we have to write 1. If there is no number, we have to write because we have to assign code. 8 is there? No. So I have given 0. 4 is there? No, because I have divided this into two parts. For this, we have to find no 4 is there, 2 is there, no 1 is there. So the code is 0010. So here we have given code for the decimal numbers. Then here for 4 is here. So 8 is not there, 2 is not there, 1 is not there. So 010. These are the codes, these are the positional weights, and these are the decimal numbers. So now what it is? So weighted binary codes are those binary codes which obey the positional weight principle because we have given weights to the particular decimal numbers. Each position of the number represents specific weights. So if it is there, we have to write 1. If there is no number, we can write 0. Several systems of code are used to express decimal digits 0 to 9. It should not exceed. So instead of 9, because if you write any number, it comes between 0 to 9, right? So it should not exceed 9. So non-weighted, there is no weight. Weighted, we can give weight. Non-weighted codes, the position are not assigned. Example, XS3 code and gray code. This is example of non-weighted code XS3. XS3 means what we have to do. Additionally, we have to add 0011. If you add 8421 plus 0011, it is known as XS3 code. So XS3 code is also known as X3 code. Non-weighted codes express decimal numbers. So to express the decimal number, we have to use the XS3 codes. So derives from 8421 BCD codes, and then we have to add 0011. So 0011 is nothing but 3 base 10 to each number. We have to add 8421. Then additionally we have to add 0011. Here I have explained two example. So decimal numbers, these are decimal numbers and BCD codes. For this BCD codes, we have to add 0011. If you add 0011, see what is the first number? 0000. 0000. This 8421 BCD codes. What we have to do? We have to add 0011. So 0011. So if you add, what is the answer? So if we add 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0, 0 plus 0. This is the answer. So 0011. This is the answer. If you add 0011 for these BC numbers, you will get the answer. Okay, is there any doubt? It is easy. It may be any numbers, 8421, it may be any numbers, but additionally we have to add 0011. Got it? Okay, next is gray code. So these are the fixed codes that we have to remember. So first is not weighted, not arithmetic codes, because here we are not giving any weight for the decimal numbers. So it means there is no specific weight assigned to each bit question, because in 8431 we have added 0011. So there we are adding specific weights to each bit question, but here we are not using any specific weight to each bit positions. So as only one bit changes at a time, not all the bits will not change. If you add 0011, maybe 2 bits may change, or 3 bits may change, or 4 bits may change. But here only one bit can change one at a time. This is known as gray code. So gray code is a cyclic code, cannot be used for arithmetic operation. It cannot be used for arithmetic operation. So only one bit can be changed. Here the answer is 1001. See, only this position has changed. Only one bit position can be changed at a time. Next is binary coded decimal. So you know the equivalent decimal number. So these are the decimal numbers and equivalent binary coded numbers that we have already seen in the tables that you know, right? There is no need to explain. But the what is the base of decimal is 10, right? It should not exceed 10. So binary code is, so binary decimal base is 10. It should not exceed. So the remaining 6 combination in the sense 10 to 15, which means A to F is invalid in binary coded decimal. It can accept only 10 numbers. Clear? Next, what are the advantages of using BCD? It's very similar to decimal numbers. Need to remember binary equivalent of decimal numbers 0 to 9. There is no need to remember. If you follow the same rule which I explained you, first we have to write 8 zeros, then 8 1, and then 4 zeros, 4 1, 00 1 0 1 0 1. If you follow this simple method, you can easily number, and you can convert any decimal number into binary numbers. It's a decimal into binary, octal to binary, there is no need to worry. So it is need to remove binary equivalent decimal numbers 0 to 9. Disadvantage, addition and subtraction of BCD have different rules. We cannot follow only one rules. For addition and subtraction, we have to follow different rules. So BCD arithmetic is little more difficult. So subtraction is easy to do, but BCD arithmetic is complicated when compared with subtraction of BCD codes. Next is alphanumeric codes. I mean, it should at least represent 10 digits and 26 letters of alphabets. So we have to represent digits and numbers. That is alphanumeric. That because when you create password, we have to use alphanumeric. So if you add 10 digits from 26 letters, total 36 items. So these are the 3 alphanumeric codes which is commonly used for data representation. One is American Standard Code Information Interchange, then Extended Binary Coded Decimal Interchange Code, 5-bit baud code. These are the alphanumeric code representation. Now error code and error detection. These are the technique which is used to detect and correct errors during data transmission and data representation. So next is micro operation. So now we have to know what is a register. A register is a group of flip-flop, which each flip-flop capable of storing 1 bit. Okay, in each register, we can store only 1 bit information. Okay, next is register transfer language. So which can be This register transfer is a notation, symbolic notation used to describe the micro operation transfer among the register. So one bit information can be transferred from one bit to other register that can be discussed further. So it is used to describe the information, and information can be transferred amongst the registers, not from memory. You can transfer information or transfer anything from register to register. So these are the commonly followed registers. One is accumulators. So accumulator can be used to store information. So this is a common register used to store data and take and out of the memory. So accumulator is used to store register information. So it can be taken out from the memory. Next is general purpose register. This is also used for data intermediate results. So accumulator, general purpose registers are used to store information of registers. So next is special purpose register. User do not access these register or computer systems. So general purpose registers are not used to store information. These are the computer register. So what are the register? One is memory address registers. These are the register that holds the address of memory unit, not that is used to store information, but as memory address registers are used to registers memory units. So next is memory buffer register, used to store instruction and data received from the memory or sent from the memory. So memory address registers is used to hold the address of memory unit, okay, in which memory position the register is stored. So address can be held in memory address registers, but memory buffer registers used to store the instruction and data received from the memory. Because in a particular register, what kind of information is stored, and it can be received from memory and sent from the memory. Piece is nothing but program counter, which is used to point to the next instruction to be executed. Next is instruction register holds the instruction to be executed. It directs next where the instruction should go and exit. So program counter, simply we can say next pointer. Instruction register holds the instruction to be executed. So next, what instruction have to be processed? So that can be identified using instruction register. Now, what is micro operation? Okay, the operation executed and data stored in register. So we can execute anything using the register that has to be stored using the MBR, MA, or program counter and in IR. Okay, using these things we can execute any operation. These are the elementary operation which performed on information stored, because only one bit information stored in a register, or if you want to store more information we have to use other things. So example, shift, count, clear, load. These are the operations. These are the example and types of micro operations. Four types are there. One is register transfer micro operation, which is used to transfer information, binary information from one register to another register, not registered to memory. So if it is a register transfer means you can transfer any information, binary information from one register to another register. Then arithmetic register, you know already about this. So using arithmetic register, you can perform arithmetic operations, okay, on numeric data stored in registers. Using the registers, we can perform only arithmetic operation like addition, subtraction, multiplication. Logic operation can be done here. Logic means and or operations, and or not operation can be done. And shift operation can be performed. It may be left or right, or circular shift can be done. These are the four operations performed in micro operation. First is arithmetic operation. Arithmetic operation consists of addition, subtraction, increment, decrement. So first, how we have to add. So R1, R2. So how this how we have to register R1, R2, R3 or registers. So we are adding R1 and R2 values into R3. So say for an example, R1 is 2, R2 is 3. So 2 plus 3, 5 is stored in register 3. So this is how we can add. So R1, R2 information is transferred to R3. So R3 stores the information of R1 and R2. So next is subtract. So you can subtract. So R1 plus R2's complement plus 1. So first we have to take 1's complement for the second value, then 2's complement. So say for an example, this is 5 and we have to complement the value of R2 and add 1 and store the value in R3. This is how we have to subtract. Next is increment decrement. If you add 1 plus the 1 plus 2 R1 registered, so value of R1 is 2, 2 plus 1 is 3, 3 is stored in R1 register. So if you subtract, so the value of R1, so the value of R1 is 3, 3 minus 1, 2, 2 is stored in R1 registers. This is how we can increment decrement the registers value. So either you can add or subtract value. So these are the some symbolic designation. So look at the symbolic designation. You can easily say so R1 and R2. This is addition, micro operation, arithmetic. So we are adding R1 and R2 and stores the value in R3. Here we are subtracting and here we are complementing. After complemented, um, adding 1 plus to the register, then after complementing the value is added and the R1 and the R2 complemented value is stored in R3. We are incrementing the content by 1 and decrementing the content by 1. This is increment and decrement operation. Next is logic micro operation, which is used to store bits of information registers. The operation have to be performed separately, and that has to be in binary values. Now we have to discuss a simple example of logic micro operations. So R1 XOR operation and R2. So R1 value is 0, 1, 0 and R2 is 1, 0, 1. Then do XOR operation. So if you add R1 value is 0, 1, 0, R2 value is 1, 0, 0, we have to do XOR micro operation. So if you add 0 plus 0, 0, 1 plus 0, 1, and 0 plus 1, 1. So 1, 1, 0, that is stored in 1. Next is shift micro operation, which is used for serial transfer of data. So which is used, shift is nothing but transferring information from one register to other register. So which is used for serial transfer of data that must be continuous, not discontinuous. So it can be shifted either left or right. First we see left, shift left. So okay, serial input transfer can be transferred from one bit to other bit. So shift left means it transfers input from right to left. So if it is a right shift, so you can transfer from left to next position. So now how many three types of shift micro operations are there? One is logical shift. So it transfers 0 through the serial input. The symbol how we can represent SHL is used for logical shift left. Shift right, logical, the symbol is shift right. The shift left, SHL used for logical shift left, SHR is used for logical shift right. So if you write like this, SHER1, SH not E, SHL or SHR, shift right or shift left. So in both direction you can do. Next is circular, that you know how we have to use CAL or CRR used for circular left or right. So CAL is used for circular left, CRR is used for circular right. So we can circulate some values. Next is arithmetic shift. So it can be shifted in two forms, one is left or right. So arithmetic shift left multiplies signed binary numbers by 2, and shift left divide the number by 2. Okay, if the shift left, you have to multiply the given number by 2. If you want to shift left, you have to divide the values by 2. These are the two simple conditions we have to follow in arithmetic shift. Next is a register transfer language. So you can transfer information of a register to other register, not to memory. So information transfer from one register to another register, not from register to memory. Okay, these are called replacement operator. So you are replacing the value of R1 into R2, which means you are transferring the value of R1 into R1 into R2. So it denotes so transfer of data from R1 into R2. This simple example of its transfer. Then control function. So we have to use zeros or values have to be there. Control function have to use like this: P of or into R1. So control function is terminated with the colon. If you write colon, P of colon. So P of colon R2 of R1. If you write colon, we have to stop the work because it has transferred the content of R1 into R2. Here we have to terminate. So if you use colon, it will terminate. So it shows the transfer operation can be executed only if P1 equal to 1. If it is like this, it has to execute. If you use colon, it has to terminate. Next is bus and transfer title is there. Bus transfer and memory transfer. Come to this picture. Look at this picture. So these are the registers. Register A, B, C, D consists of three, and this three it has three. All register has three inputs. These are the multiplexer, 4 into 1 multiplexer. Here we have to give four values, and S1, uh, S0 or S1 serial input, and four lines of common bus. So these are four lines of common bus which is used to give inputs. Okay, we have registers, 4 into 1 multiplex, 4 multiplexer, and 4 line common bus serial inputs. Here we can give only one input can give at a time. So now look at, so bus transfer is used to transfer information between registers in multiple register configuration. So we can transfer any information from register to register, that may be between registers, not registers to memory, and it consists of common lines. What is common lines? See, four common bus. So it has common lines, one for each bit registers. So registers A, B, C, D are registers. We have common bus and registers, and through which binary information stands for one at a time. Only one register stands for one at a time using common bus. And control signals determine this control signals which is used to select only one input at a time using the register transfer. Okay, it is constructed. So the registers are constructed, A, B, C, D register are constructed with the help of 4 into 1 multiplexer. So 4 into 1 multiplexer, using this register you can construct. So each having four inputs. It as each multiplexer has data inputs. So we can give um, two inputs at a time. Two inputs at a time. These are the general explanation of this block diagram. Next is So two selection lines, S1 and S0, or otherwise you can say S1 or S0. So these are the two selection lines which are connected to these selection inputs for multiplexers. So these are the four multiplexers. So serial inputs are connected, and from each register only one input can be given. Next is selection lines. Choose 4-bit information registers and transfer them into 4-line common bus, because from each and every registers, the selection line is used to select only one input. So selection line is used to select here. For registers can give only one input at a time, so which can be selected using S1 and S0 serial input using common bus. So if you look at the picture, you can easily understand. And the inputs, if when the both of the selected lines are low logic, when S1 S2 are 0 0. If it is S1 S2 or 0, it is low. When S1 and S0 0 1, register B is selected. If S1 and S0 0, we can say register A is selected. This is how we can select registers. So because we have four registers A, B, C, D. So if you give input S1 and S0 or serial inputs, if you give 0 0, we have to consider register 0 selected. If it is 0 1 B, 1 0 C, 1 1 D. So if you give these input, we can select any one of the registers and give input. So the system can be constructed using three-state gates instead of multiplexer, because four into one multiplexers are there. Instead of multiplexer, we can use three-state gates. So three-state gates is nothing but normal input and output, normal input, normal input A and B, and we can get output. This considered as three-gate. Three-gate considered as logic circuits are three gates. Two are first, two are used to give input. One is used to get output. That's all. So three-gate exhibits in high impedance states. This is how you have to give high impedance in sense. So if C is equal to 0, output is 0. If output is 0, we can consider as high impedance. Further, the diagram represents 3-bus state for. So instead of common multiplexer, we can use um, the gates A, B, C, D, and instead of multiplexer, we can use a decoder, 2 into 4 decoder, and either you can enable and disable, and we have to select using the registers, and finally we'll get the answer. So outputs generated by 4 buffers are connected from single bus. The single bus, all the 4 registers are connected using a single bus lines, and only one instruction can be executed at a time, and the 2 into 4 decoder is used to control all the things. Next is memory transfer. So memory transfer is nothing but transfer of information from memory unit to the user end. Here there's no need to use registers. So memory transfer is used to transfer information from memory unit to user ends. So it's called read operation. Write operation is transfer of new information. Transfer of existing information is known as read information. If you want to write any new information, that can be stored using a write operation. Then memory word, if you want to use letters using M. So memory word is designated by the letter M. Next is we must specify the address memory word while writing the memory address because we have to use letters. Next is address registers designated by AR and the data registers designated by DR. These are the terminology we have to use in memory transfer. And read operation can be stated as how we have to state the read operation. If you want to read a thing, we have to state like this. So AR is nothing but M. AR is nothing but address registers. M is what? M is memory word. So it is transferred to data registers. So this is how we can transfer information. So read state causes transfer of information data registers. So address registers, address registers information is transferred to data registers. Memory selected by the registers. So any information is selected by the address registers from memory word, and information is transferred. Memory word and address registers transferred to data registers. And corresponding writing operation can be given like this. So R1 is nothing but registers. Registers information is transferred to this what I say address registers and memory word. See, the statement calls transfer information from register into address registers and memory word. This is general pictorial representation. Address registers, memory word. It may be we can write or we can read and write. You can give in, data output, and that can be processed by address selection, address registers. Next is shift micro operation. So which is used to transfer serial transfer of information. You can transfer information one after the other, uh, one after the other, not from one place to first place to fourth place. You cannot transfer, which is used to transfer information one after the other. First one is logical, so it can transfer the zero through the serial input. If it is all the inputs is zero, so I'll explain it through the simple example. Logical shift left, how you can shift information. So this is least significant bit, this most significant bit. These are the logical shift. You can give any numbers. See if, here you we have to shift. We have to insert zero. So see 1 1 1 0 0 1 1 0 1. So one bit is transferred here, one is transferred here, and one is transferred here. So we have to transfer the information one after the other. So finally this zero is added here, zero is added here, and all the other information is transferred one bit. So 0 1 1 0 0 1 1 0. Got it? This one is carry. So this is how we have to transfer information serially. So logic shift left. So we can move one bit to the left position, one by one, not one by two. So we can move one bit to the other bit. So empty least significant bit is filled with bit zero, and most significant bit is rejected. If there is anything, it has to be rejected. See, the least significant bit is filled with zero, and one is rejected. That is the most significant bit that we have to be rejected because it carries one. That should be rejected. Even it may be one or zero, that has to be rejected. Next is right right logical, that you have to rotate from left right left. So zero is added in more significant bit, and the least significant one is rejected. So we have to move bit one after the other. So got it? So 0 stands for to the most significant bit, 1 stands for here, and other thing is stands for one after the other. Arithmetic that we have already discussed. So it may be sign numbers to the left or right portion we can move. If it is arithmetic shift left, the given number is multiplied by 2. If you want to do arithmetic shift right, the given number is divisible by 2. So we see left arithmetic shift. So it moves, one portion moves each bit to the left one by one. So we can move one of the other and from left side, most significant bit is filled with 0 and most significant least significant bit is filled with 0, most significant rejected. Because this we have already seen, same as left logical shift. So in most significant bit, 0s um, filled, 0s filled, and most significant bit is rejected. See here, we have added 0, 1, 1, 0, 0, 1, and this 0 should be added. This 1 should be added. Right. Arithmetic shift. If you look at the picture, you can easily know because this same as the previous one and circular. So we have to circulate sequence manner. The shift circulate the bits in sequence of register around both ends without any loss of information. So circular left circular shifts. So these are the given numbers 1 0 1 1 0 0 1. So first, what we have to do is we have to move one bit. See, 1 0 0 1 1. This most significant bit is not rejected here. Instead of that, we have to circulate this value to least significant bit. This is how it circulates. So left circulate, right circulate, there's an opposite of left circular shift. If you look at the picture, you can easily understand. So there's least significant bit is circulated to most significant bit, and each bit portion is transferred one by one. Next is arithmetic logic shift unit. So in short, we can say ALSU, arithmetic logic shift unit. So there's a number of arithmetic logic unit in the computer which comes under, even if there's arithmetic logic shift unit, it comes under arithmetic logical unit. It's a member of ALU in a computer system, and ALU is nothing but arithmetic and logical unit, which is used to perform arithmetic, logical, and shift operations. So arithmetic logic unit is used to perform addition, subtraction, multiplication, and that leads to a result and gets transferred to a designation results. So register information can be transferred. Information can be transferred from one register to other register. So what are the things we can do? Arithmetic addition, subtraction, multiplication. These things we can do. And arithmetic logic unit is a combinatory circuit, and that will that have complete registered operation that supplies the register through arithmetic logical unit and the destination register is performed throughout one clock pulse. That is nothing but only one register can be transferred at a time. So S1, S2, S0, S1, S2, S3 or inputs. So one stage uh, arithmetic circuit, and here logic circuits. So these are the 4 into 1 multiplexer, and finally it gives input. So after doing the arithmetic operation, here it does the logic operation, and both inputs are given to the multiplexer, and multiplexer does some function, gives us output. So here we can shift right and shift left function can be do. So these are the function we have to do. Then we are giving here as input, multiplexer does some function and gives us output. So these are the operation selection. So input, so operation A, we have to transfer A. If you give 1 here, A plus 1, we have to increment the value of A. If you give 1 0, it means addition, subtraction, addition function have to do. If it is F equal to AB plus AB plus 1, addition with carry, subtraction. These are the operation, these are the function we have to do. If you want to do these things in operation selection, we have to give these results. According to the results, it operates and does some function and gives us output. Next is microprogram control. Microprogram control, which is used to generate control signals with the help of micro instructions stored in control memory. So all these things can be done with the help of micro instruction. So program control initially generates the control signal with the help of micro instructions stored in control memory. It is slower and other instruction when compared with the other instruction, it is slower, and we can easily modify anything in using micro program control unit. So less costlier than hardware control, and compared with hardware, micro program control is less costlier. So because which is used for transferring control signal, and it is a complex instruction, so it can handle microprogram instruction can handle complex instruction, but hardware control is not handle complex instruction. Control is transferred from many instruction can be generated using microprogram control. It can be used in computer to perform many complex, and it is use of sys computer set computer instruction set computer. It can be used in hardware microprogram control. So types of microprogram control further classified into two types. One is horizontal microprogram control unit, which is used to specify different micro operations to be performed. So microprogram is further classified into two types. One is horizontal. So what the exact work of horizontal microprogram control? So microprogram control unit is used to specify many different micro operations to be performed. So we have to use wide memory word, high degree of parallel operation is possible. So internal CPU control signal, micro instruction, these are the things we can do in horizontal microprogram control unit. And next is vertical. Here each micro instruction specified signal part to the what we performed. Here if they use F1, that has to be performed first, and F2, F3. First, it has to complete vertical manner with the arrow N control encoded with log 2. So some operation can be performed using micro instruction address. If these are the function, here it does according to the function and gives us output. Then address sequencing. These all comes under microprogram control unit. First, initially, it has to load into the control address register when the power stand off turned on the computer. So we can do anything when the computer is turned on, and this usually address the first micro instruction that activates the instruction fetch routine. If we give any function, it routinely works. Next is types. Um, Sequencer, routine mapping, process of address sequencing, control unit, hardware control, micro program control, micro instruction, micro program, or comes under address sequencing. So what is a sequencer? So it's the next address generator. We have already seen about the program counter, which is used to perform next activity. So sequencer is also does, and it directs to the next address generator and it can also used to select address for controlling the memory. And routine, so which is used, I mean routine is stored in control unit in group, or it may be stored in specific group. Each computer instruction has its own microprogram routine. Each and every computer instruction has its own microprogram routine. Microprogram routine is nothing but uh, for each instruction have separate function. And mapping instruction code is nothing but where the routine is located. Instruction code is find out where the routine is located. Using the memory address, we can locate the instruction code. Next is control memory, uh, which is used to initiate the sequence of address of microprograms and control signals bus organized system by the group of selected path, because instruction, I mean input can be given using the multiplexer or decoder, which may be group or a single. That input can be selected using the multiplex or decoder. The control memory is further divided into two types. One is hardware control, micro instruction. So hardware control is the control logic is implemented with gate, flip-flops, decoders, and other logic circuits. Using this, we can do any function. Next is micro instruction. The instruction stored in microcontroller that we have already seen. The micro instruction nothing but an instruction stored uh, in memory, control memory is known as micro instruction. Next is microprogram example. So because we have already seen microprogram, so programs are stored in memory that generates all control signals. Because using decoder and multiplexer, we can pass any control to the program that is stored in memory, and which can be execute instructions set correctly. According to the instruction, it works perfectly. Then next, and it consists of micro instruction. And micro instruction contains sequence of words and word control. Here it consists of two things. One is sequencing word and control word. And the control words is all the information required for one clock pulse. So using one clock pulse, we can transfer any information and control micro instructions. And the design of control unit. This is also a part of central processing unit, which directs the operation of the process. So central control unit is also a part of central processing unit. So with if you do anything, uh, that can be done only in central processing unit. So control unit is a part of CPU, and the control unit is included as a part of von Neumann architecture by John von Neumann, because John von Neumann is a modern father of computer. So in modern computer, it was included, and it has a responsibility of control units to tell the computer memory and where the function, what it does. So control unit is used to instruct the computer um, what kind of information I mean the control processing unit has to do. It may be arithmetic or logical unit, and everything is instructed by the control unit. Look at the diagram and you can understand. So instruction registers. So what it is control unit? What is the responsibility of the control unit? It has to instruct how. So it tells the computer's memory, arithmetic logic unit, and input output devices how to respond to the instruction that have sent to the processor. So some instruction is sent. So instruction using instruction register, we are giving some instruction to the control unit. The responsibility of the control unit is to direct the control to the control bus. and whether we are passing signal to the control bus, or a signal is coming from the control unit, or we are doing some process. What are the process? Arithmetic logic unit, arithmetic function, addition, subtraction, multiplication, and other things. And we have to give input, and we can get output from the concerned bus. So these are the responsibility. So it instruct the computer memory, and what function, whether it does arithmetic or logic unit, or whether we are giving input and output, and which is used to respond to the instruction that have been sent to the processor, and fetches introduction and process and gives us input. Next is function of control unit. What it does, it coordinates the sequence of movements in or out, whether the control is transferred in or transferred out. So it coordinates between processor or many sub units. So interpret the instruction. So if you use logical unit, it interprets how we have to do only logical instruction. If you use arithmetic, particularly add micro operation, then control unit, it instructs to the particular operation to do only particular operations. So this is how it interprets instructions and controls data flow inside the processor, which is used to control. So according to the instruction, we get input, so which is used to control data flow, and receives a external instruction or commands, which is used to convert sequence of signals. These are the functions of control unit, and which is used to control many execution units, not only ALU, data for bus registers. So it can control. So it also handles multiple tasks, not only one task. If you give multiple instruction to the control units, it can handle. So such as fetching, decoding, execution handling, and storing results can be done only in control unit. Next, it is further classified into hardware control, microprogram control, that we have already discussed. So hardware control is nothing but control the logic to be implemented with gates. Hardware, all the operation can be done only with the help of gates, flip-flop, decoders, and other digital circuits. See, all the information can be done with the help of gates. Yeah, this is decoder and the instruction registers, and according to the input, it processes and gives us output. These are the instruction code. Instructions can be given using instruction registers. So here we are using 3 into 8 decoder and 4 into 16 decoder. We can use any multiplexer or decoder to do some process. So 4-bit sequence, here we can increment the value and clear the value, and we can give one clock pulse. Here we can increment the instruction or decrement the instruction or clear. Only for this purpose we have to use bit sequence counter. So it consists of hardware control consists of 2 decoders and sequence control number of logic gates. We can use number of logic gates, not only one gates, XOR, X star, and or not. We can use any gates, but it consists of two different decoders sequence counters. And instructions fetched from the memory unit and placed in instruction registers. So it fetches instruction from the memory unit and gives the instruction to the instruction register and process using decoder, and according to the instruction, using some gates, it performs operation and gives us output. And the component of instruction fetches 1-bit operation code and bit 0 to 11. So instruction register includes these things. So operation code 12 to 14 is coded with 3 into 18 decoders, 3 into 8 decoders. Output of decoder is designated by D0 to D7. So this can be designated by D0 to D7, and bit 15 is used to transfer to flip-flop, simple one. And operation code bit 0 to 11 are operated to control logic units. So operation codes are there from 0 to 11, controlled by the logic units, and the code bit 15, which is used to transfer to flip-flop, and computer sequence can count from 0 to 15. So sequence counter where we can increment and clear the value. Only for this purpose we are using sequence counter. So microprogram control. So microprogram operation performed by executing program consists of micro operations that we have seen lots of micro operations. After this, unit 1 is over. Now we come to unit 2. So unit 2 consists of central processing unit. So central processing unit is used to perform arithmetic logical unit. Control units we have already discussed, and control units consist of general purpose registers, stack organization, instruction formats, addressing modes, data transfer and manipulation, program control, risk pipelining, arithmetic and instruction, risk pipeline, and vector processing and array processing. First, we discuss about central processing unit. You already know uh, central processing unit is used to perform all kinds of arithmetic and logical unit, under which we have to see general registers. What is a general registers? So general registers can use 2 or 3 address fields in the instruction format. So not only one address fields. In general purpose, in if you use general registers, we can use more than 2 address fields in the instruction format. Each address field specify a general registers or memory word. These are the two things here. So these are 3 address fields in the instruction. So each address field may specify general register or memory word. So R1, R2, R3 are registers that has to be multiplied. So instructions given arithmetic multiplication is an assembly language. It uses 3 address fields R1, R1, R2, R3. So 3 address fields. One is R1, R2, R3, and remaining instruction. How we have to, if you want to multiply, we should not write like this. So we have to multiply R1 into R3, and this result is stored in R1. So this is 3 what to say 3 address fields, and that can be reduced into 2 addressing fields, and we can also rewrite like this: multiply R1 comma R2. If you write like this, R1 and R2 values are multiplied and stored in R1. If you write codes like this, R1 R2 value is multiplied, that's all. But here we cannot store any value, but uh, we have to write like this. So we can write using 2 addressing fields or 3 addressing fields. So advantage, large number of registers are used, because here not only one register using, large number of registers are used, less memory space used to store the program. It cannot occupy much memory space. Less memory space used to is occupied to store the program. Disadvantage, care should be taken to avoid unnecessary usage of registers, because for what purpose we are using the registers. Simply we cannot write multiply R1, R2, R3, R4, R5. So we have to avoid to use unnecessary registers, and a large number of registers are used. Thus, extra cost is required to use register. It needs extra cards. A large number of registers are used in what is it? General registers. So next is general register is further classified into register memory assurance architecture. So it uses CPU with less registers. So first the sources registers, second is used present in registers to memory. So source one is nothing but R1, which is always required in register, and source 2 can be represented either in memory or registers, which means memory registers. So information can be transferred from register to register or register or memory. So this is called register memory reference architecture. True address instruction formats can be used here, not three, only two. The second is register to register. So information can be transferred from register to register. Here we can perform arithmetic logical operation only on registered data, not memory. If it is registered memory, we can use memory also. If it is register reference architecture, any operation can be done only with the help of registered data. Okay, the operands required in register, all the manipulation, all the calculation can be done only with the help of register and placed in register. See, arithmetic operation multiply R1 into R2. So using the register, we are multiplying and storing the value R3 equal to R1 into R3. So we are multiplying the value of R1 and storing the result in R3. So three address registers can be used here, but register memory only two address instruction can be used. Okay. Next is stack organization. Next type is stack organization. Can anyone tell me what does it mean by stack? Could you please tell me what does it mean by stack?
Storing data, sir.
Last in
Because we have already read the operation of stack. So if you tell me, it will be easy to understand. Could you please tell me what does it mean by stack? So what you told me is correct.
Stack is an abstract data type.
Next. Memory. Okay. Shall I explain you through a simple example?
Yes, sir.
Okay. See, this is stack, right? This is known as stack. And this position starts from 0, 1, 2, 3, 4, and 5. This is 5. So you can add 6 values here. So maximum stack is maximum stack is 6. Only 6 values are added in this stack. So 5 is known as top of the stack. So this is base. So you can add only 6 values. The fifth position is known as top of the stack. So if you add, so I'm going to add 4 values. So the values are 16, 20, 4, 7. So I have to add the values in the stack. So suppose if I add 16, it will be stored here, right? 20 will store here, 4 will store here, and 7 will store in third position. So I have added, how many values I have added in stack?
4.
4 values.
Okay. If I want to add 3 values, what I have to do?
You have
So
to
I
insert.
so I'm going to add 44, 77, 43. So 44 will add here, 77 will be here. So I want to add 43. So where can I add?
16 will go out, I think so, sir.
See, I have told you that maximum stack is 6,
6.
which means how many values you can add in a stack? Only 6 values you can add in a stack. Okay. So if you want to add 43 in stack, what you have to do, you have to delete an item from the stack. Then only you can add. So for 44 is there, 77 is there, stack is full. So which means you cannot add any value in the stack. If you want to add one value or two value, you have to delete an item from the stack. So what is this top of the stack value?
77.
Okay. So if you want to add any value, we have to use push. Stack has two operation. One is push. Push operation is used to add an item into the stack. Pop operation is used to delete an item from the stack. So stack has two operation. Is it clear? Push is used to what? For what purpose? For what purpose we have to use push operation? For what purpose we have to use force pop operation? Can anyone tell me? If I want to add, if I want to delete an item from this stack, which operation I have to use?
Pop.
Okay, pop. Pop operation is used to delete an item from the stack. So pop. So we have deleted 77 from the stack. If I want to add 43 into the stack, which operation I have to use?
Push.
Using push operation, I can add an item into the stack. Now the stack is full. So instead of 77, 43 as filled. So I have added 16 first. Is it possible to delete 16 first?
Yes, sir.
No. So which is last in
First out.
First out.
got it. So what we have had lost, that can be come out first. Okay, got it. You
Yes, sir.
now you understood what is stack. So what are the operations of stack? So this is stack organization, so which is based on stack based CPU organization. So it is called, these are the basic concept of data structure called stack. So it is a list of data words, I mean list of items can be added and it uses last in first item, first out, because uh, what either for 73 or 43 that has been added into the stack last, that can be that is the first output, right? If we want to delete an item from the stack, what have added last, that can be removed from the stack. Got it? So it uses last in first out access method, which is the most popular access method most of the CPU. Next, stack pointer. Okay, which is used, stack pointer is used to store the information, store the address of the topmost element of the stack. So the memory address, say for an example, the memory address is 00, here triple zero 1, this is 2, 3, 4, 5. So stack pointer is used to store the address of the topmost element of the stack. So fifth position 0, 1, 2, 3, 4, this is 5. So what is the address of stack 5? 005. So 005 is a stack pointer where we have stored 77. Got it? So 70 stack pointer is used to store what? 005 is what? Memory address, right? Is it clear? So 0, 1 to all positions. In 0th position we have stored 16, but 16 is stored in triple zero. This memory address 0th position, the value 16 is stored in triple zero memory address. In triple zero, 16 is stored. Okay, so stack point is used to store address of the topmost element. Only topmost element address is stored. So only for this purpose we have to use stack pointer. So it is further partitioned into three segments. One is program, second one is data, and third is stack. So program counter we have already discussed, which is used to address the next instruction in the program. So if 77 is deleted, then top of the stack is 4, where 44 is stored. So program counter is used to execute next instruction in the program. Okay, address registers points at an array of data. See, program counter, array registers, these are the registers, program, and it is further divided into program unit and stack. This we have already seen. Stack pointer is nothing but which is used to store address of the memory, topmost stack memory. Next is stack operation, push and pop operation. Push operation is used to insert an item on the top of the stack. So using pop, you can add any item into the stack. Pop operation is used to delete an item from the stack. So what are the advantages of using stack? So complex arithmetic expression, execution of instructions fast because operand data are stored in consecutive memory locations. Consecutive memory locations is serially 0, 1, 2, 3, 4. So it is data stored in consecutive memory location. So each instruction works faster. So length of instructions short. They do not have address fields because we are not using registers or memory board. So length of instruction will be very short. Disadvantage, size of the program increases. So we have to write length of code. Next is instruction formats. Here we have to use three things. One, operation field, address field, and mode field. So address field specifies the operation to be performed, like addition, subtraction, multiplication, maybe anything. Address field is used to um, represent only a register or memory location. Operation, what kind of operation we are going to perform. whether it may be arithmetic operation or logical operation. Operation field denotes this. Then address fields is used to register address location or memory location, mode field, and how operand is to be found. So these are the three common fields are used in instruction formats, and further classified into three types. One is single accumulator organization, general register organization, and the third one is stack organization. And we have a number of address instruction. One is zero address instruction. See, zero address instruction, nothing but we are going to add two values. First, a, we are adding a into a, stack, and again we have to push b into stack. So a and b values are pushed in, added into the stack, and we are using multiplication operation, then it does multiplication. So here we are not using any address field. To evaluate this, we have to use this expression. So x is equal to a plus b into c plus d. So BODMAS rules. BODMAS rule is nothing but bracket of division, multiplication, addition, subtraction. Got it? We have to follow this rule. BODMAS is nothing but BODMAS stands for bracket of division, multiplication, addition, subtraction. So first, what we have to do, if it is postfix, see postfix in the sense a plus b, we have to write post. We have already read prefix postfix in common English. So if it is, so the operation has to come right side. So a plus b, then c plus d. So c, d, then addition operation. Why the multiplication has come last? So we have to follow BODMAS rule. So division. So division is not there. Next multiplication. So I have written multiplication here. If we have used postfix, everything has to come right hand side. If it is prefixed, a plus ab, multiplication plus cd. So these are the reverse Polish notation. There is no to discuss more about the reverse Polish notation. So top means top of the stack. So we are going to push A, B, C, D items into the stack. Push A means it will be in the top. Then push B, we are adding one more item into the stack. To now B will be on the top of the stack. We have to add A plus B, top A plus B we have to add. Then again we are pushing one more item C, that will be on the top of the stack. Then D, again we have to add C plus D. So if you want to multiply, we have to use mul. So top is equal to C plus D into A plus B. Okay, then value will be stored in X register. That's all. Next is one address instruction. Here we can use accumulator. AS is nothing but accumulator. M in that may be stored in any memory location. Empty is nothing but temporary memory location. So result can be stored in any temporary accumulator location. So load is nothing but we have to load an accumulator in this memory address. So AS is nothing but accumulator where we are loading A. Then add B. A's value is stored in accumulator, then B's value have to be added, and these two values is stored in accumulator. Then accumulator value is stored in temporary locations. Again, we are loading C, then add D, then multiply that value with accumulator, then store that value in X positions. This is easy to understand. Two address instruction. Here we have to use two registers. So the value of A is stored in R1 register. Again, B value is added with R1 register, because A's value is stored in R1 register. With R1 register, we have to add B's value, then uh, move the value of C into R2 and add R2's value with the D, then multiply, store the value in X. Then three address instruction. Here also we have to use two registers, which is easy to understand. A, B's values are stored in A register, and we have to add A and B values and store in R1 register. Then CD values are stored in R2 register, multiply two values and store in X, at X register. Then addressing modes. These are the types of addressing mode which is used to specify the location of an operand in an instruction is called addressing mode. So these are the types of addressing modes. Um, One is implied, stack addressing mode, immediate, direct addressing mode, indirect, register indirect, relative addressing mode, index addressing, base register, auto increment, auto decrement. So implied addressing mode, which is nothing but instruction itself specify the operand. Stack, so it is contained top of the stack where we can add, or we can add an item, delete an item using stack operation. Intermediate addressing mode, instead of address mode, an operand field is present that contains the operand. Here we have to use instead of address field, we have to use operand field. These are the definitions that you can simply read. So immediate addressing mode, instead of half code, we have to use operand. See, add 10, move or. So we are moving or register from one place to other, one register to other register using move command. Address field, direct addressing mode. See, opcode is A, that values is stored in memory, that is operand. Address fields of the instruction contain effective address. So memory address, so A's value is stored in memory, which has specific memory address. Only one reference to the memory is required to fetch operand. So if you want to fetch the value of A, we need only one reference of operand. Example, accumulator, and the X values is stored with accumulator, that is stored in accumulator. Indirect, so address of memory location that contains effective address. If you look at the example, you can easily understand. See, opcode A, EA, then operand memory. So register direct, register, it contains register set. Address field of the instruction set refers to the CPU registers. So register set is stored here, no reference is required. Where here in direct addressing mode we need reference. In register direct addressing mode we don't need any reference. The operation or values is stored in the memory, which has register set that can easily retrieve any value. These are the simple example. And register indirect. See, here we have to use register set, then we need reference. So address field of the instruction refers to CPU register that contains effective address. For this register, we have register set and we have memory address, because we need reference to fetch any value. Using the memory address, we can fetch any value. So relatively addressing mode, we have to adding the content of program counter with the address part of the instruction. So what is the definition of relative addressing mode? The content of program counter along with we have to add address part of the instruction, that is known as relative addressing mode. Next is indexed addressing. Index is nothing but content of index register by adding the content of address spot instruction. If you look at the table, you can easily understand. So operand is obtained by adding to the content of index registers with address part of the instruction is known as index addressing mode. The example, general example, and base registers. Here we have to add content of base registers with address part of the instruction. Content of base registers and address part of the instruction. If you add this, we known as base register, and the auto increment, that content of register which can be increment and decrement. So using the register, we can add or decrement. So application of using addressing modes, immediate addressing modes, which is used to initialize the register, direct and register addressing mode. Direct addressing mode is used to access static data, and direct addressing mode is used to implement the static data variables. So that we have already seen applications here they have given. Next is data transfer and manipulation.